Hey everyone, this is homework 1.16. Today we went over systems of equations, but when we have something that isn't super obvious to cancel out and we have to multiply one of our equations by something else to help eliminate one of those variables. So we are going to start by looking at the homework, and I'm going to go back and I'm going to look at question number 3 in your classwork. Remember, if you do that, I will give you extra credit, so you can do that with me if you'd like. All right, so looking at the first one, it says solve each systems of the equations. If you need more room, which you might, that's fine. You can use a separate piece of paper, but we're going to go ahead and do this first one. So this first one is nice in that this second term here has opposite signs. Ooh, let me get my pen together here. There we go. However, if we have to multiply something to get a opposite coefficient, we're going to have to multiply both equations. And so it might actually be easier for us to multiply something for x to eliminate x. So in this case, I'm going to eliminate x, and I'm going to multiply the second equation by -2. This is going to give me -2x minus 10y minus 80, or sorry, equals -80. Equals -80. There we go. And then I'm going to combine that with 2x minus 4y equals 10. This is the y. It's not a very good y. There we go. All right, these will now cancel out and be left with -14y equals -70. Divide both sides by -14, and we will get y equals 5. All right. So if I plug that in, let's plug that in the second equation. X plus 5 times 5 equals 40. X plus 25 equals 40. Subtract 25 from both sides, and then x equals 15. So for letter A, our solution is 15, 5. So that's one way that we could have solved it. To me, that's the easier way to do it, is to multiply the second equation by -2. However, let's say we wanted to do it eliminating the y. You could do that as well, but we'd have to multiply both equations. So the lowest, least common multiple here is actually going to be 20. And so that would mean that I would need to multiply this one by 5 and this one by 4. You can multiply both equations by something as long as you multiply the entire thing. So we have 10x minus 20y equals 50. And then we would have 4x plus 20y equals 160. This is going to cancel out, and we'll be left with 14x equals 210, I believe. Yes. And then if we go ahead and we calculate, you can use your calculator for this if you like. You do 210, I'm opening my calculator. 210, divide both sides by 14, you get x equals 15, which we also found here. So if you were to substitute that back in and solve for y, you would get y equals 5. So I'm just showing that there's two ways, there's many ways that you can solve these, right? That's just one way to do it as well. Let's take a look at the next one. So the next one has opposite signs in the y values and opposite signs in the x values. However, neither of them can easily be, hold on, let me pause my notifications here, okay? Okay. Neither of them can easily be multiplied by something to cancel out. We have to look at the least common multiple here. So the least common multiple for 3 and 2 is 6, and that's a little bit smaller. For 5 and 6, it's going to be a larger number. And so I'm going to go ahead and use the 3 and the 2, and we're going to eliminate the x. The least common multiple for 3 and 2 is 6. So I want to multiply the top times 2, because that'll give me 6x. And I'm going to multiply the bottom by 3, because that's going to give me -6x. So let's go ahead and do that. 2 times 3x is 6x. 2 times -5y is -10y equals 8. And then 3 times -2 is -6x. 3 times 6 is plus 18y. And then 3 times 18 is 24. Carry the 2 is 54. Now I'm going to go ahead. This will cancel out. We're left with 8y here equals 62. So we are not going to get a nice even number here. So 8y equals 62. Divide both sides by 8. If you do 62 divided by 8, you'll get 7.75. So y equals 7.75, or 7 3/4. And we'll plug that in for x to solve for x. So 3x minus 5 times 7.75 equals 4. So 7.75 times 5 is 38.75. So we'll get 3x minus 38.75 equals 4. Add 38.75 to both sides, and we'll get 42.75 equals 3x. 42.75, divide both sides by 3, will give us 14.25. So our x equals 14.25, and our y equals 7.75. So 14.25 comma 7.75. All right. Again, that's a little bit more work, but there you go. You got it. All right. So when you have a system in which it isn't easily apparent or obvious to multiply one of the equations by something to equal the other and get an opposite number for a coefficient, then you might have to multiply both equations by something. Let's look at number 2. Tyler is solving the system of equations. He can think of 2 ways to eliminate a variable and solve the system. So his first way is to multiply this top part up here by 2 and then subtract the result. And then it says his other option is to multiply 8p minus q equals 59, so the bottom one, by 2, and then add the result to 4p plus 2p equals 62. So he wants to know, do both strategies work? Why or why not? So let's try the first one. Strategy 1, 2 times 4p plus 2q equals 62. Remember, we're multiplying the whole thing. I almost made a mistake there. Equals 62. And so then we're going to get 8p plus 4q equals 424. And then we will have 8p minus q equals 59. He says then subtract. So we're going to multiply this whole thing by -1. And we'll get negative 8p plus q equals negative 59. And then we have 8p plus 4q equals 124. This will cancel out. We'll get 5q equals 124. And negative 59 gives us 65. Divide that by 5, and we get 13. So q equals 13. And then we could solve for p. So this does work if you multiply the top and then subtract. But we have to make sure we do that subtraction piece. Strategy 2 says, can we multiply the second equation times 2? So 8p minus q equals 59, which would give us 16p minus 2q equals 59 times 2 is 118, right? Yeah, 118. And then we have the other equation, which was 4p plus 2q equals 62. And he says then you can add the result. So let's try that. We get 20p. These cancel out. We have 62 plus 118, which is going to give us 180. And so 180 divided by 20 is going to give us 9. All right. And so both of these would work. Both strategies work. Because in the first one, we cancel out the p's by subtracting, and in the second one, we cancel out the q's because they already have opposite signs. Let's try number 3. Andre and Elena are solving this system of equations. Andre's first step is to write 3x equals 9x minus 30. So what Andre did is he said, well, y equals 3x, so I'm going to substitute y in the second equation. So that does work, yes. Andre used substitution. Then Elena says she created new systems. So she multiplied this top equation by 3 and made 3y equals 9x. And then we have y equals 9x minus 30. Okay, so if Elena were to continue along this, she would then have to do 3y minus 9x equals 0. And then I suppose we could do 9x minus y. So 9x minus y and add 30 to both sides, and we would get equals 30. Okay, so now the negative 9x and the positive 9x can cancel out. We're left with 2y equals 15. And so then y would equal, sorry, I got ahead of myself. 2y equals 30. So then therefore y would equal 15. Okay. If we were to solve then y equal 15, x would equal 5. And that does in fact work for the first equation too, because we would get 5 for that equation as well. So both are good first steps, both work, but Andre's is preferred, all right? So that's what I would say. I agree with their first step. They're both things to do. We can do both of them. But I would say that Andre's is easier to use substitution when you have both y equals. You just set them equal to each other. That's a lot easier in my opinion. A little bit less work. So this was yes, used, elimination. Okay. Number 4 is select all systems that are equivalent to this particular system right here. All right, so we're looking for all of the equivalents that would, all of the equations or all of the systems that would be equivalent to this. So we're looking to see if they multiplied something, did they multiply it through the entire thing? All right, so for number 1, this part right here, they multiplied 9 times 5 to get 45, and then 9 times 0.5 to get 4.5, but they did not multiply this. So that is not true. That does not match. All right, in letter B, it looks like they multiplied the whole top thing by 5, and everything in here has been multiplied by 5. And the second equation has been left alone, so this looks fine. So the main point of this is to make sure that whatever they multiplied one of the equations by, they multiplied through the entire thing. So same thing here. This is accurate. That works. It's the same as the one above. Here they multiplied by 6. So 6 times 5 is 30. 6 times 0.5 is 3. And 6 times 4 is 24. So C is also correct. For letter D, they multiplied, the first equation is the same. They multiplied the second equation. Well, let's see. We have 6D plus 0.6E equals 4.8. So to get from 5 to 6, right, 6 divided by 5, they multiplied by 1.2. That's a very interesting thing to do, but they did it. So they did 1.2 times 5D plus 0.5E equals 4. Well, let's see if we get the same answer. So if we get 0.5, 1.2 times 0.5, that does in fact equal 0.6, 0.6. And then 1.2 times 4 does give us 4.8. So this one is also true. They just multiplied by 1.2 in order to make this a 6. Quite interesting. All right. Letter E says they multiplied the first one by 2. So that checks out, that checks out, that checks out. And then they multiplied the second equation also by 2. So 2 times 5 is 10. Ooh, but 2 times 0.5 is not 0.5e. So they did not multiply the entire thing. So that is not true. Letter F, first equation is the same. Second equation, they multiplied to get from 5 to 11. So they multiplied by 2.2. 2.2 times 5d plus 0.5e equals 4. If we multiply 2.2 times 0.5, we get 1.1, not 5e. So this is what is wrong here. that is not true. All right. Number 5, we need to solve this system of equations.